So we've been going to begin talking about complex numbers, chapter 5.6, complex numbers. A complex number is of the form a plus bi, where a is called the real part and bi is called the imaginary part. So the idea of imaginary numbers came about from looking at the square root of a negative number. We know that we can't find the square root of a negative number, so someone came up with the idea that if we took the square root of -1, since we can't do that, we can give it a designation as I, an imaginary number. And this idea can stretch downward. For example, if I started off by saying I squared, that would be -1 squared, which would be -1, and I cubed would be, so this is -1, I cubed would be I squared times I, which is I times 1, sorry, 1 times -1, which is, I'm sorry, 1 times, I'm mixing that up. This is -1 times I, which is -I, and I to the 4th power would be I squared times I squared, which is 1 times 1, or 1. I want you to see the pattern here. So I squared is -1, I cubed is I to the 4th power is 1. And if we keep going down the cycle, I to the 5th power, we're going to have, now we know that I to the 4th power is 1, so this is I to the 4th power times I, which is I'm sorry, yeah, so that's I to the 5th power is equal to I, okay? Because we started off with I being the square root of -1. So I to the 6th power is I to the 4th power times I squared, which is 1 times 1, 1 times -1, -1. I to the 7th power is I to the 4th power times I to the, no matter what combination you take here, you're going to be at the same place, I to the 3rd power, which is 1 times -I, which is -I, and I to the 8th power is I to the 4th power times I to the 4th power, which is 1 times 1. So I to the 8th power is equal to 1. So this cycle keeps repeating, -1, square root of -1, and then the cycle continues to repeat. Then I squared to -1, I cubed to negative I4 to I8. So every fourth power of I squared is equal to 1. And that we can use that to our advantage to calculate really large powers of I. For example, if I have I to the 16 power, using the rules of exponents, this is I to the fourth power times 4, which is 1 to the fourth power, which is equal to 1. Anything that's any power that's exactly divisible by 1 is equal to 1. If we have I to the 17th power, this becomes I to the 16th power, which we know is equal to 1 times I. So this is equal to 1 times I, which is I to the 19th power. So 4 fours are 16, 4 fives are 20. So I to the 16th power times I cubed. And we know that I cubed from our little algorithm, I cubed is negative I. So this is 1 times negative I is negative negative I. I to the power 22 is I to the 20th power, because 20 is exactly divisible by 4, I squared, which is 1 times negative 1. I squared is negative 1. So this is negative I. I to the 65th power is I to the 64th power times I, which is 1 times I, or I. I to the 104th power. So 104 is exactly divisible by 4, so that's equal to 1. I to the 123rd power, which is I to the 120 times I cubed. Okay, I to the 120th power is 1, because that's exactly divisible by 4, so this is 1 times, and then I cubed is negative I. So this is negative I. FYI, so just in case you're wondering, if I divide 123 by 4, 4 threes 12, 4 fives are 20, and remainder 3. So this is 120 plus 3. Now you're probably asking yourself if you can do some of this with the calculator. You may be able to do this with your calculator depending on the age of your calculator. However, the calculator loses some of its functionality um, um, after you go too far on I. You would have to press the mode button, scroll down to where it says real 1 over to A plus BI, and press enter. Clear. And the calculator is now in the complex number mode. So if I were to take the second square root of negative 1, I would see I. Okay? Or if I were to access I, just press second and the period key to the power 4, I would get 1. or if I pressed I to the power 63, I would get negative I. Or if I pressed I to the power, 95, I would get negative I. At a certain point, you're not going to be able to put in any more powers. For example, if I tried, let's see, 123, the calculator is not able to compute that. So at a certain point, you're going to have to figure it out manually. Okay? So going back to what we're talking about here. So one second here, please. I just wanted to have a brief discussion about negative powers of I. So if you're dealing with, say, I to the power -1, this first has to be written as negative 1 over I using the power exponents. This is not evaluated by substituting a value for I. Instead, we use a process similar to rationalization, where we multiply both numerator and denominator by I, and this becomes I over I squared, which is I over -1, which is negative I. Or I to the power -6, which would become 1 over I to the power +6, which is 1 over, the way you would evaluate this is, so I to the 4th power times I squared, which is 1 over 1 times -1, which is 1 over -1, which is -1. I to the power -12 becomes 1 over I to the power +12, which is a number, 12 is a number that's exactly divisible by 4, so this is I4 to the power 3. I to the power 4 times 3, which is 1 over 1. Finally, I can take, say, I cubed with you, I to the power -3, sorry. So I cubed to see this, we would look at it at 1 over I squared times I, which is 1 over I squared, which is -1 times I, and this of course would be equal to negative I over -1, which is positive I, because we figured out that 1 over I is equal to negative I. Okay, so pay attention to this right here if you're asked to do something like that. Okay, 1 over I is negative I right there. All right, so taking our discussion a step further, we can go ahead and look now at, say, something that's a square root. If I'm asked to find the square root of -36, the process then would be to say this is the square root of -1 times 36, But the square root of -1 is I, so this is I square root 36, which is equal to 6I. This has no real part, so the actual complex number is 0 plus 6I, where it only has an imaginary part. 0 is real, the imaginary part is 6I. By the way, the calculator would give you the answer as 6I if you tried it. Remember, our calculator is still in the complex mode. And if you enter it, you will see 6I. Or say the square root of -144. So we can get in the habit of taking that -1 and putting it outside as I, which is 12I. This becomes really interesting when we're dealing with negative square roots multiplied. The rule is no longer to multiply -8 times -3. Instead, we convert it to a complex number. So this will become I square root 8 times I square root 32. And now we can go ahead and use the multiplication property for radicals that says we multiply what's underneath the radicals if the radicals are the same, if the powers of the radical are the same. So I times I is I squared, 8 times 32. So this is I squared is equal to -1. So this is -1 times the square root of 256, which is square root of 256 is -16, so -1 times 16, or solution -16. You can do that in the calculator. This would be square root of -8 times the square root of -32, and you get -16. Now, I want to show you the incorrect way to do this. This is what would be considered as very incorrect. -8 times -32 square root, and if you did it where we multiplied before we took out the I, we would get -8 times -32, which is positive 256, which is positive 16, which would be an incorrect answer. Okay, because this method is incorrect when working with complex numbers. All right, more examples. So 10I times -7I, this is multiplying across. This is 10 times -7 is 70. I times I is I squared. So this is 7 times -1. I squared is equal to -1, which is this is -70 times -7 is positive 70. Just coming back to a real number and imaginary numbers again. A complex number, remember we said in the form a plus bi. So examples of that could be 3 plus 2i, could be negative 17 minus 5i. It could be negative 3 over 2 plus 17 over 2i. Okay. Or it could be a number that's only imaginary, 0 plus 7i. This is called pure imaginary. Purely imaginary. And a real number, such as 5 plus 0i, has a 0i for the imaginary part. So a real number can be written in terms of a complex number. Okay? Now let's look at how we add or subtract. Adding and subtracting. This is simply done by collecting like terms after you distribute the sign. So 8 minus 6i plus 5 minus 2i. If we remove that plus sign, this becomes 8 minus 6i plus 5 minus 2i. So here we've got 8 and 5, 13, and then negative 6 plus negative 2i is negative 8i. This is our complex number. If we're subtracting, we follow the same process. This is 5 minus 3i minus 7 minus 8i. So this is 5 minus 3i, and then distribute that negative 1 to negative 7 and positive 8i. Remember, negative times negative becomes positive 8i. So 5 minus 7 is negative 2, and negative 3i plus 8i is positive 5i. Yes, you can do this with your calculator. For example, 5 minus 3, to access I just press second and the dot. I'm sorry, this is minus 3i minus 7 minus 8i, and the calculator provides the answer for you is negative 2 plus 5i, which is confirms our answer that we have here as negative 2 plus 5i. Multiplying, so use FOIL. For example, negative 1 minus 3i, 2 plus 2i. So first, negative 1 times 2, outside, negative 1 times negative 1 times 2i inside, negative 3i times 2, and last, negative 3i times 2i. So negative 1 times 2 is negative 2. Negative 1 times 2i is negative 2i. 2 times negative 3i is negative 6i. And last we have negative 3 times 2 is negative 6i squared. So I squared is equal to negative 1. So we've got negative 2, negative 2i and negative 6i is negative 8i. And then right here we've got 6 times negative 1. Negative 2 minus 8i plus 6. So collecting like terms, we have 6 minus 2 is 4 minus 8i. To divide, we have to pick our battles really carefully. So dividing, oh yeah, and you're probably asking if you can do this problem with your calculator. Yes, you can, or you can check it with your calculator. You should know how to do it. For example, I have negative 1 minus 3i, oops, open parenthesis, negative 1 minus 3i, close parenthesis, multiplied by 2 plus 2i, close parenthesis, and yes, you can get 4 minus 8i from it. Now dividing, I'm going to just go over a couple of division problems here for you to show you the process. So the one given here is negative 4 minus I over 3i. The process is similar to rationalization, where we multiply both numerator and denominator by 3i, because we need to clear that I from the denominator. So this becomes 3i into negative 4 minus I over 3i times 3i. Distributing the numerator, we have negative 12i minus 3i squared over 9i squared. Now, we have to go ahead and work on simplifying this. Remember that I squared is equal to negative 1. So this becomes negative 12i minus 3 times negative 1 over 9 times negative 1, which is negative 12i plus 3 over negative 9. So we're getting ready to write this in the complex form. We have to remember the real number goes first, the imaginary number goes second, and now we have to split this up into the real and imaginary parts. So 3 over negative 9 minus 12I over negative 9. Both terms on the numerator get divided by negative 9. So this is negative 1 over 3 plus reduce 12 over 9 to 4 over 3. So plus 4 over 3I. It is now in the A plus BI form. Question has been, one more example here. Oh yeah, I just wanted to make sure that you know how to put this into your calculator as well. So be very, very careful when putting this into the calculator, okay? Negative 4 minus I divided by 3I. You want this answer in the fraction form. So math, press the math button, number 1, and you get the fraction form of the answer, which is the answer that we have, 1 over 3 minus 4 over 3I. 1 over 3 minus 4 over 3I. I'm going to do one more example for you with division. 2 minus 6I over negative 4 minus 7I.